segments of the session. In the earlier sessions, we have concentrated on Laplace transform, and in this session, we will concentrate on numerical on Laplace transform and its properties and transform theorems. So let us consider the first problem. F of t is equal to sine 2t into sine 3t. Now here this f of t is a product of two trigonometric functions, sine 2t and sine 3t. So for a product of trigonometric function, we don't have any properties in the Laplace transform. So we need to convert this product of trigonometric function into linear combination of trigonometric function. Linear combination in sense, this product has to be converted into sum of the trigonometric function. So how to convert? So we have already know from the trigonometric functions, sine A sine B equal to half into cos A minus B minus cos A plus B. Sin A minus B equal to half into cos A minus B minus cos A plus B. So using this, we need to transform the multiplication product of two trigonometric functions into sum of the two trigonometric functions. So if I convert this, so this becomes half into cos 3t minus 2t. Larger one I will consider as a A, smaller one as a B. So cos A minus B minus cos 3t plus 2t. So it becomes half into cos t minus cos phi t. So this now f of t has changed from product of trigonometric function to sum of trigonometric functions. So now f of s, Laplace transform of f of t equal to half is a constant. So based on a linearity property, k into f of t is equal to k into f of s. So half into, now here this is based on superposition property, cos t cos phi t, sum of the two functions, so equal to Laplace transform of individuals. So Laplace transform of cos t is s by s square plus 1 minus s by s square plus 25. So this is f of s. After simplification, half into, take a LCM, s square plus 1 into s square plus 25. So if I take this one, s into s square plus 25 minus s into s square plus 1. So what will happen? S into s square s cube minus s into s square s cube. So 25s minus, so it is 24s by s square 2 into s square plus 1 into s square plus 25, which means 12 as divided by s square plus 1 into s square plus 25. So this is the Laplace transform of sin 2t into cos 3t. Similarly, now instead of sin, if it is cos A into cos B, so how to convert this? This is equal to half into cos a plus b plus cos a minus b. So converting product of two cos function into sum. Similarly, sin a cos b equal to half into sin a plus b plus sin a minus b. So cos a sin b equal to half into sin a plus b minus sin a minus b. So using this, we have to convert product of cos into cos or sin into cos or cos into sin into sum of the signals, sum of the trigonometric function. Now next category, f of t is equal to sin square 2t. So here also we don't have function for f of t is equal to x square of t. Such function we don't have. So we need to convert this into linear combination. So we know that cos 2a equal to cos square a minus sin square a, or 1 minus 2 sin square a, or it is also equal to 2 cos square a minus 1. So using this relation, sin square a equal to 1 minus cos 2a divided by 2, or cos square a, it is not only for sin square, even I am telling for cos square a equal to 1 plus cos 2a by 2. Now using this formula, converting into sin square into cos, linear combination, this becomes 1 minus cos 4t by 2. So f of t equal to 1 minus cos 2t by 2. So f of s, what happens is f of s is equal to half is a constant, once again using the linearity property. 1 is 1 by s minus 4t, s by s square plus 16. So by taking the common denominator, half into s into s square plus 16, if I take a common denominator, s square plus 16 minus s square. So s square gets cancelled, 2 ones are 2 8s are. So it is 8 by s into s square plus 16, s into s square plus 16. So this is the Laplace transform of sin square 2t. So if similarly if they ask for cos square 5t, so we need to convert using this transformation, this formula, product into sum. Cos cube 5t. Cos cube 5t. F of t is equal to cos cube 5t. So how to find a Laplace transform? So similarly cos square, there is no function. Similarly for cos cube, we don't have function directly. So we need to write cos 3t. So cos 3 theta is equal to, we have formula that 4 cos cube theta minus 3 cos theta. Now from this, what is cos cube theta is equal to? From this, cos cube theta is equal to cos 3 theta minus, sorry, not a minus, plus cos theta divided by 4. So now this cos cube theta is transformed into sum of the trigonometric signal. So if I substitute this formula here, this cos cube phi t becomes cos 15t plus 3 cos phi t by 4. Now this f of t is this. So Laplace transform f of s equal to 1 by 4 into cos 15t, that is s by s square plus 15 square 225 plus 3 into s divided by s square plus 25. So by taking a common denominator, 1 by 4 s square plus 225 into s square plus 25 equal to, sorry, in the numerator, s into s square plus 25 plus 3s into s square plus 225, that is equal to 4s square, 4s cube plus 25s plus 675, 700s divided by 4 into s square plus 225 into s square plus 25. So it is equal to s cube plus 175s divided by s square plus 225 s square plus 25. So this is a Laplace transform of cos cube phi t. Similarly, if suppose sin cube theta is asked, so that we need to find sin 3 theta equal to 3 sin theta minus 4 sin cube theta. So from this, sin cube theta equal to 3 sin theta minus sin 3 theta by 4. So using this, sin cube theta has to be converted into 3 sin theta minus sin 3 theta by 4. Then take a Laplace transform. Next, f of t is equal to t cos at. So t into cos at. One is a polynomial and another one is cos at. So this I can rewrite as t into e to the power j at plus e to the power minus j at by 2. E to the power j at plus e to the power minus j at by 2. So this can be half into e to the power j at into t plus e to the power minus j at into t. So we have property shifting property as e to the power minus at f of t equal to f of s at s is equal to s plus a. Right? F of t e to the power minus at f of t is equal to f of s, s is equal. So what happens is e to the power minus jat t becomes, it is Laplace transform of t, that is f of s, at s is equal to s plus jat. S is equal to s plus jat. So that means Laplace transform of t is 1 by s square at s is equal to s plus jat, that is equal to 1 by s plus jat whole square. S plus jat whole square. So 1 by s plus, in the denominator there is a complex term. So what I need to do is 1 by s plus jat whole square, I will multiply with s minus jat whole square, both numerator as well as denominator. Oh, sorry, not a jat, ja. No t, s is equal to s plus a. So this becomes, in the denominator, s plus ja whole square, s minus ja whole square becomes s square plus a square whole square. S plus ja, s minus j is equal to s square minus j square a square. J square is equal to minus 1, so s square plus a square. So in the numerator, s square minus a square minus j 2as. A square plus b square, ja, so minus a square minus 2as. Now what happens? E to the power jat into t, Laplace transform of t at s is equal to s minus ja. That means 1 by s square at s is equal to s minus ja. That equal to 1 by s minus ja whole square. Now if I multiply numerator, so s plus ja whole square divided by s square plus a square whole square. So it is s square minus a square plus 2jas divided by s square plus a square whole square. Correct? Now, what is f of s now is, f of s is equal to half into Laplace transform of this. So, Laplace transform of this, Laplace transform of this. So, half into s square plus a square whole square divided in the numerator s square minus a square minus plus j2as plus s square minus a square minus j2as divided by s square plus a square whole square. So LCM is common, so this two gets cancelled, so remains s square minus a square divided by s square plus a square whole square. So this f of t is equal to t cos at is transformed into exponential, and then we have applied shifting property. So based on that, Laplace transform of t cos at becomes s square minus a square divided by s square plus a square whole square. So similarly, it may be asked for t sin bt. So if it is sin bt, then here it becomes a minus and in the denominator 2g. Then later procedure remains the same. Next, f of t is equal to e to the power minus 3t into this. So this I can write as f of t equal to 2 e to the power minus 3t cos phi t minus 3 e to the power minus 3t sin phi t. Now what happens is f of s equal to 2 into Laplace transform of e to the power minus 3t cos phi t minus 3 into Laplace transform of e to the power minus 3t sin phi t. So equal to, so f of s equal to 2 into Laplace inverse of e to the power minus 3t cos phi t minus 3 into Laplace transform of e to the power minus 3t sin phi. Now this Laplace transform of e to the power minus at into f of t, we know that. So this is 2 into Laplace transform of cos phi t at s is equal to s plus 3 minus 3 into Laplace transform of sin phi t at s equal to s plus 3. That means Laplace transform of cos phi t is s by s square plus 25 at s is equal to s plus 3 minus 3 into Laplace transform of sin phi t is omega by s square plus omega square. So s into s by s square plus 25 at s is equal to s plus 3. So it is 2s divided by 2 into s plus 3 divided by s plus 3 whole square plus 25 minus 15 divided by s plus 3 whole square plus 25. So denominator is common. So s square plus 6s plus 34, 9 plus 25. In the numerator 2s plus 6 minus 15. So it is 2s minus 9 divided by s square plus 6s plus 34. So this is the Laplace transform of e to the power minus 3t 2 cos phi t minus 3 sin phi t. So first separation, then applying a properties, and hence find Laplace transform of the given function. Next, find the initial values and final values of I of t equal to 3 e to the power minus t minus e to the power minus 2t. Now, we know that using Laplace transform to find out the initial value and final value, we need to find Laplace transform of I of t, that is I of s. So I of s is equal to 3 into 1 by s plus 1 minus 1 by s plus 2. So this is the Laplace transform of I of s. Now initial value f of 0, sorry, not f of 0, I of 0 equal to limit as s tends to infinity, s tends to infinity, s f I of s. That is limit as s tends to infinity 3s by s plus 2, s plus 1 minus s by s plus 2. Now if I substitute s is equal to infinity, then it is infinity by infinity, infinity by infinity, which is undetermined form. So before applying s is equal to infinity, I will modify it as 3 divided by 1 plus 1 by s. Dividing numerator as well as denominator by s. 3 divided by 1 plus 1 by s minus 1 by 1 plus 2 by s. Now if I substitute s is equal to infinity, it becomes 3 minus 1 equal to 2. So I of 0 equal to 2. Now I of infinity final value is equal to limit as s tends to 0 s f of s. Limit as s tends to 0 s f of s. So it is limit as s tends to 0 3s by s plus 1 minus s by s plus 2. So if I substitute s equal to 0, it is 0 by 1 minus 0 by 2 equal to 0. So initial value is 2 and final value is 0. So like this we need to find initial value and final value using Laplace transform. In this session we have studied how to find Laplace transform of given function by applying properties, by applying theorems, and by applying some mathematical skills. We will solve few more problems in the upcoming sessions. Thank you.